Hello and welcome to another pvlib Python tutorial. In this video, we will learn how to get POA data for a specific location and a specific year, and how to use it within our pvlib model. POA data is plane of array data, and it basically means that it is the irradiance that hits our PV module depending on the angle in which it's oriented. While before we were working with the irradiance data that hits the flat ground. So I'm going to go back to PVGIS and again select the cathedral I've been working on. And I'm choosing hourly data this time. And I'm also going to choose the year 2020 for my case. And now we also have to provide the orientation of our PV modules. In my case, I chose 45 degrees as the slope of my modules. And regarding the azimuth, so the orientation east, north, south, west, it's a little different than within pvlib. If we have a look at the user manual, we see that 0 is considered south, while inside of pvlib, 180 is considered south. So I'm gonna enter 0 here. So I have a southern orientation, 45 degrees. And I'm gonna click CSV. So what I'm getting here now is data, PVGIS. I'm going to call it PVGIS 2020 global. And we see why in a second. 2020. And I'm also going to check this radiation components and download this CSV file as well. And I'm going to call it PVGIS 2020 components. So if we open this data, this one here and the other one as well, we can see that the files contain different time series. So the one I called global actually contains the global irradiance. We can go all the way down to the end of the file. So it's the global irradiance on the inclined plane, so the plane of array. And the other file contains different parts of this. So the first one is the beam, so the direct irradiance, and then we have two kinds of diffuse irradiances. The first one is the diffuse irradiance, which comes from the sky, so from clouds and so on, while the second one is the reflected diffuse irradiance that comes from the ground. And these two together make up for the overall diffuse irradiance that we will see for our PV modules. So just like for the TMY data, I'm gonna pre-process. So I open up a new file and I'm gonna import pandas SPD, and I'm gonna read in these two files. The first one I'm gonna call global 2020, and I read in pd.read CSV, and I'm gonna read in PVGIS 2020 global.csv. I'm further going to specify, if we have a look at the files again, we see that the first 8 rows we don't need, just like before. We're going to skip them. And the other thing is that actually 2020 is a year where February had 29 days, so we're gonna have more than the 8,760 hours in that year. So we're gonna have to add 24 to that. So first we're gonna skip the rows. Skip rows 8. And we're gonna take n rows of 8,784. I'm gonna do the same for the other file. They have pretty much the same structure. I'm gonna call this one components 2020, and of course change the file name. So print, so we see what we're dealing with, and the other one as well. So now I'm going to save this file in the same directory. Process POA.py and hit F5. So here's our data. We see we started January 1st, we end at December 31st. I don't know actually why they have these weird timestamps of 10 minutes past the full hour, but we don't bother about this right now. So what we're further gonna do, I just noticed we're gonna use the first column here, again the time, as our index. So we say index column equals 0. Same for the other one. Perfect. And now we can have a look at the function we actually want to use. We're gonna run our model chain, this time with the function run model from POA, because it's a different kind of data than the one we used before. And the columns that are required are POA global, direct, and diffuse. The optional ones are air temperature and wind speed, which we also have, so we're gonna include those. But this means we have to reformat our data and do a little bit of calculations. So I'm first gonna create a data frame, POA Data 2020 equals pd.data frame, and I'm gonna add the columns we will need in order for pvlib to process the data. So the first one be POA global. The next one is POA direct. Then we have POA diffuse. Diffuse, the air temperature, temp air, and the wind speed. All right, and we can actually define our index already, because it's going to be the same one as for the others. So index is equal to, let's just take global 2020.index. All right, and now we have to add the data from the two data frames we imported from PVGIS into our newly structured data frame. And I'm basically gonna include it in all these lines. So I'm gonna say POA Data 2020, and then POA Global, which comes from this data, and in the original form it's just called GI, like here. So next, I'm gonna add POA Data POI Direct, which comes from the components and is originally called GBI for beam, just like we had it with the TMY data. So now I'm gonna copy this line. Come on, it's a little faster. For diffuse, air temperature, and wind speed. So diffuse, actually we need to do some calculations because diffuse consists of these two. So we have the diffuse irradiance from the sky plus the diffuse irradiance coming from the ground, which is this line. So we're just gonna add them up and we have our total POA diffuse radiation. Great. So the next one we need is the air temperature. So in pvlib it's temp air, and the last one is wind speed, and then we can copy those over as well. All right, and then we can have a look at our POA data. Gonna comment this one out, we don't need that. And run. Great. Last thing we need to do is reformat our timestamp in the beginning here. So we create a new index. You know that from the previous tutorial. POA data.index equals PD to datetime. Oh, to datetime. There you go. And we need our index, and we need to define the format as a string, which is in the form of the year, the month, the day, then the colon, then we have the hours and the minutes. Nice. Run this again. We have our nicely formatted timestamp with the weird time. All right, now we have our data in the right format, and we can actually go ahead and save it. So we say POA data to CSV, and I'm just gonna call this POA data as well. .csv. Run again. Nice. If we now go back to our pvlib model, we can comment out what we had before for the TMY data, and then we're gonna import our POA data by saying pd.read CSV, and we're gonna import this one .csv. We specify the index column, which is the 0th, and then we convert the index again to datetime, which is not saved in the CSV, unfortunately. PD to date time dot index, and then we can include it in our model chain. We say model chain dot run model, and this time we say from all the way down there from POA, and we add our data. Now we also want to see the results, so I'm just going to copy these 2 lines over and uncomment them again. And if I don't have any typos, we have a nice figure of our solar yield for the year 2020 using plane of array data from PVGIS. Of course, if you have any other source of plane of array data, you can also use that one and include it with the same methodology I showed you here in the processing steps. That's it for this tutorial. If you ran into any issues so far, let me know in the comment sections below. Also, if you have any questions, comments, whatsoever, feel free to comment below as well. As always, stay curious and kind, and we'll meet again in another video. Bye!